The Open Systems Interconnection or OSI model is a template for standardizing the functions of a communications system in terms of layers. It was jointly published in 1984 by ISO and CCITT, which is now known as International Telecommunication Union. A layer is basically a group of related functions. This standardized approach helps in developing any protocol in communication system with specific functions. Without layered approach, it is difficult to build a system or network. Let's look at the 7 layers in OSI model. At the top is the user interface, since users work directly with the applications. The higher layers are more concerned with the users and logical aspects of communication, while the lower layers are more concerned with the physical medium functions such as voltage or frame formats. Layer 1 represents the lowest level. This includes the physical communication line and its electrical signals, whereas the layer 7 is in user level, which makes the data model possible for two devices to exchange and interpret data. Each layer adds its own header to the packet that was transferred from the upper layer. At the transmission source, headers are added on with appropriate information at each layer. The data link layer does error checking and adds the trailer. At the receiver, the reverse process occurs. Each layer reads its header and other appropriate information and passes the data to the layer above it until the application receives and recovers the information completely. Before going through the functions of layers, we must know that each layer in OSI model provides service to the adjacent layers. Now let's look at the functions of each layer. First one is application layer. This layer supports application and end user processes. Whatever we see in the browser window is a part of this layer. This layer is available only at the source and destination nodes. In our example, source node is a server and destination node is a computer, or it can be vice versa. Presentation layer is the second layer from the top. This layer formats the data to be presented to the application layer. It is the translator for the network. It converts data from a format used by the application layer into a standard format at the transmitter. On the other hand, presentation layer also helps in data encryption. For example, when we type password, this layer encrypts before transmitting to the actual network. Third layer is session layer. This layer coordinates and terminates conversation between the application at each end. It also provides checkpoints that synchronize the data flow between the application. Checkpoints are markers in the stream of data. For instance, in case of failure in the flow, only the data from the most recent marker needs to be retransmitted. Fourth layer is transport layer. The transport layer ensures that messages are delivered error-free in sequence and without losses or duplication. The size and complexity of a transport protocol depends upon a type of service it can expect from the network layer. If the network layer offers reliable connection, a minimum transport layer is required. Or if the network layer is unreliable, the transport protocol should include extensively error detection and error recovery. TCP and UDP are some of the examples for this layer. Then comes the network layer. The network layer controls the operation of routing of packets. This layer decides which physical path the data should take based on the network conditions, priority of service, and other factors. IP comes under this layer, and we will discuss more about this layer in subsequent slides. Data link layer. At this layer, data packets are encoded and decoded into bits. It handles error in the physical layer, flow control, and frame synchronization. The data link layer is divided into two sublayers. First one is media access control and second one is logical link control. Media access control deals with the physical layer connection and type of access used in it. For example, MAC layer for Wi-Fi deals with the wireless access method, whereas MAC of LAN works on wireline access technology. This function is stored in network interface card of the computer. Logical link control or LLC controls frame synchronization, flow control, and error checking. The last layer or the first layer from the bottom is physical layer. The physical layer, the lowest layer of OSI model, is concerned with the transmission and reception of unstructured raw bit streams over a physical medium. Raw bit means just ones and zeros in digital communication, independent of any application. It describes the electrical, optical, mechanical, and functional interfaces to the physical medium and carries signals for all the higher layers. In cellular network, this layer deals with frequency of operation.